In this video, we are going to identify terms of geometric sequences and write a formula for the nth term of these sequences. A geometric sequence is a sequence in which each term after the first is found by multiplying the previous term by a constant, which we'll call R, the common ratio. So geometric sequences is all about multiplying to get to your next number in the pattern or sequence. So we have two examples here of geometric sequences. On this first example, it looks like to get from 3 to 15 to 75 to 375, each time they're going to be multiplying by 5. So our common ratio in this example is 5. For geometric sequences, you have to multiply by the exact same number each time, or it is not a geometric sequence. So the ratio has to be the same. And the second example that we have here, this sequence is still a geometric sequence. However, to get from 81 to 27, it looks like, we are decreasing, but it looks like we're decreasing by a factor or a ratio of 1/3. So it looks like we're dividing by 3 or multiplying by 1/3 as our common ratio. So a common ratio can be a fraction, or it can be a whole number. So for us to better understand geometric sequences, we have to understand the formula that is used to obtain terms in geometric sequences. On this formula, whenever you see a n, so a sub n, n is considered a counting number. That's the number that you're trying to get to. Whenever you see a sub 1, this is always your first term. What is the first term in your pattern of numbers? Whenever you see R, that is the common ratio. What are you multiplying by each time to get to each number? And then that is going to be raised to the counting number that you're looking for minus 1. So basically, the previous term is what I like to think of. All right, let's jump into an example. In example 1, we need to write an equation for the nth term of the geometric sequence, -6, 12, and -24. And then once we write that equation, we need to find the fifth term of this sequence. So I know some of you were like, well, they already gave us 1, 2, 3 terms. I can go ahead and just count or multiply to get to the fifth term. Yes, this is true, but what if you were asked to find the 100th number in the sequence? No one is going to sit up there and multiply up to 100 times. So let's figure out how we can write an equation to quickly get the number that we want. There's two things that you're going to need when you are writing these equations. You're going to need the a sub 1, or the initial value, and you're going to need the common ratio. So for us in our sequence, the initial, or a sub 1, is -6. That's the first number in the pattern. And then the common ratio, let's see what's happening here. To get from -6 to 12, I know they're multiplying by 2, but how did that become a positive 12? I needed to multiply by -2. So -6 times -2 will give me a positive 12. Positive 12 times -2 will give me -24. So my common ratio is -2. Now that you have those two pieces, let's make this look like an equation. So a sub n is equal to -6 times, and I like to put my r in parentheses, -2 raised to the n minus 1. So this is our equation. That's part 1. Now let's use this equation to find the fifth number. So a sub 5 is equal to -6 times -2 raised to the 5 minus 1. because what number comes before 5? 4. So let's rewrite this. A sub 5 is equal to negative 6 times negative 2 raised to the 4th power. And then from here, we're just cleaning this up using math. So A sub 5 is equal to negative 6 times negative 2 to the 4th power should give you 16. And then lastly, negative 6 times a positive 6. So the 5th number in this sequence is negative 96. And we could have figured that out by simply following the pattern and multiplying down. So we can check our answer like that. So if we start off with negative 6 times negative 2, which will give us positive 12. Positive 12 times negative 2 will give us negative 24. Negative 24 times negative 2 will give us positive 48. And then finally, positive 48 times negative 2 will give us negative 96, which is what we got. Let's try another example. But this time, our common ratio is going to be a fraction. So we need to write an equation for the nth term of the geometric sequence 5, 12, 128, and 32. And we need to find the 5th term of this sequence. All right, so just like the previous problem, there's only 2 things we need to figure out. The a sub 1 and the common ratio. So the first number in our sequence is 512. But to get the common ratio this time, we're decreasing. So to go from 512 to 128, looks like we're decreasing by a factor of 4. If you're ever, well, 1/4, sorry. If you ever are trying to figure out the common ratio and you can't think about it, take the second number and divide it by the first number. So 128 goes into 512 1/4 times. You can even do that with 32. You can take the third number and put it into the second number. So basically take a number and put it into the previous to figure out what the actual common ratio is. So for us, that is 1/4. So R is equal to 1/4. So let's make this look into an equation. A sub n is equal to 512 times 1/4 raised to the n minus 1. So there's our general equation. You should definitely see n's in your equation because you don't know what number you're looking for. And now we're looking for the 5th number. So let's see. A sub 5 will be equal to 512 times 1/4 raised to the number that you want minus 1. Well, I want the 5th number, so 5 minus 1 should give me 4. And I'll write it down, 5 minus 1, and then I'll rewrite it. But once again, you're just putting the previous place, so 4. All right, do not be afraid of this problem. Let's just clean it up a little bit. A sub 5 is equal to 512 times 1/4 raised to the 4th power. Well, 1/4 times 1/4 times 1/4 times 1/4 is 1/256. All right, and then lastly, 512 times 1/256 is simply 2. So the 5th number in this sequence is 2. And we can, like we did on the previous problem, just check our answer by following the pattern. So first we had 128 by dividing by 4 or multiplying by 1/4. Then we had 32 if we multiply by 1/4. Then we had 8 if we multiply by 1/4. And then finally we have 2. So that is what we wanted. All right, that is how you can write an equation and use that equation to find numbers within the sequence. Now let's look at a different type of formula that they may use with geometric sequences, and this is called the recursive formula. The recursive formula is very easy because it just takes our previous term So this is your previous term. Whenever you see n minus 1, you think previous. And multiply it by your common ratio. So it's just a different way to look at the formula. The rule of multiplying by the common ratio does not change. So let's look at examples. A sequence can be generated by using a sub n is equal to 4 times a sub n minus 1, where a sub 1 equals 6 and n is a whole number greater than 1. So basically, n has to be greater than 1. You can't say that you're looking for the negative second number in that sequence. That doesn't even make sense. So any number that you're looking for has to be, what is the first number, the second number, the third number, a counting number greater than 1. And so we're looking for the first 4 terms in this sequence. Well, first things first, they told us our first number is 6. So a sub 1 is 6. Then looking at this formula, to get to any number that you want, you take the previous number and multiply by your common ratio of 4. So 6 times 4 is 24. 24 times 4 is 96. And then lastly, 96 times 4 is 384. So those are the first 4 numbers in this sequence. All right, let's try another one. A sequence can be generated by using the formula a sub n is equal to 2 times the previous term, where the first number in the sequence, or a sub 1, is equal to 5. And we need to find the first 4 terms of that sequence. Okay, so when you look at the recursive formula, I do want to make note of this. You're looking to find, okay, what is the common ratio? And looking at the example or the formula that I gave you, the common ratio is always being multiplied in the front. So I want to make note of that before I end the video. That is always the common ratio, the number being multiplied in the front. So our first number is 5. The common ratio is 2. So 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. And those are the first 4 terms of the sequence. I hope this video better explains geometric sequences and how to use their formula to identify terms within that sequence.